discuss position versus time graph. The slope of position time graph always gives you velocity or speed. But the x1, x2, x1 minus x2 divided by t1 minus t2. Okay, next. This is position versus time graph. Next, velocity time graph. Velocity versus time graph always gives you acceleration. Acceleration is rate of change of velocity with respect to time. v2 t1 minus t2. And one more very important thing is the area of velocity time graph always gives you distance or displacement. This is very important. And acceleration, assign it is meter per second square. Very simple one. Next, there are so many Newton's equations. As we know, acceleration du by dt. This is instantaneous acceleration, as we can write in instantaneous velocity. Limit delta t tends to 0. V is equal to delta x divided by delta t, which is equal to dx by dt. Similarly, the acceleration is instantaneous delta v by delta t dv by dt. Okay, a is equal to dv by dt. dv is equal to a dt. Consider acceleration is a constant, uniform. The object is moving in a uniform motion. Integrate on both sides. V naught t naught. Okay, differentiation cancel. Okay, v minus v naught is equal to a t1 minus t naught. V is equal to v naught plus a t1 minus t2. This is first Newton equation. Second one, v is equal to dx by dt. Similar to this. Okay. dx is equal to v dt. As we know, a is equal to v by t. V is equal to at dt. Okay. Integrating both sides. X naught x1, t naught t1. dx replace a of t dt. Here consider t naught is equal to 0, v is equal to v naught plus at. Okay, we are putting that value in here. X minus x naught v naught t plus a half at square. This is the second equation of at square. Next, from a is equal to dv by dt, we can write this one as dv by dx by dt. Then write this dx by dt is equal to v from the instantaneous formula. V dv by dx. You can write this as v dv is equal to a dx. Integrating on both sides, v naught v, x naught x, v1 square, v naught square, 2 pi divided by 2 is equal to ax minus x naught. Okay, this third. Okay, these are Newton's equation. Very important thing, when t1 is equal to t2 is equal to, in average velocity formula, velocity v1 plus v2 divided by 2, average velocity when t1 t2 are equal. Next, another important one, when s1 is equal to s2, 2v1 v2 divided by v1 plus v2. These two are very important results about average velocity. You can use it in variety of problems used. They are help in problem statement. This topic, relative velocity. Lots of problems are based on this topic. We're solving lots of problems based on this relative velocity. Consider two objects, A, which is moving with a velocity va, and B object which is moving with a velocity vb. Okay, when an observer is at stationary, we actually see the object moving with its own speed. But now observer is not stationary, we create a reference of frame with respect to his velocity. Okay, what is meant by reference of frame? Every person is having their own reference of frame. So there are three coordinates, x, y, z. It's a three-dimensional structure of an object. With this, when we add a clock, we actually created a reference frame of one of the moving object. Okay, let's move back to our original topic. So here the observer is moving, so we are saying the velocity of the particular object with respect to his velocity. That's here the both A and B are moving in a same direction, so we can say VBA. It's a velocity of an B with respect to A is equal to VB minus VA. If VB is greater than VA, then this will be positive, otherwise it will be negative. Okay, this is one. Similar to the velocity of A with respect to B is VA minus VB. Okay, this is one of the conditions. Second condition, if the B observer, if the B is not moving, VB is equal to 0. VAB is equal to VA. We are going to see the actual speed of that velocity if the observer or any other object is at rest. That's why we are see the train moving with its actual speed, because we are at stationary. But while a person in another train, he will see the train is moving with some with respect to him with a different velocity. Next, third one. What happens if two objects move actually opposite to each other? Then consider one of the velocity will be negative. We'll take V is equal to minus A. VBA will be VB minus VA. V minus of minus VA, V plus VA. The magnitude is with respect to any, the relative motion is always greater than velocity of A or B, but not in these conditions, it less than the actual speed of both of the object, but here it is more. Let's VAB minus VA minus VAB minus VA plus VAB. Then here we can see magnitude of both the relative motion of both objects with respect to each other is more than their actual velocity, individual velocity. We have to remember these concepts because we use this formula in every